Hey everyone, and welcome. Today we're tackling a Leetcode problem called longest binary subsequence less than or equal to k. It sounds a bit complicated, but don't worry. We're going to break it down step by step and find a really clever and efficient way to solve it. Let's get started. Alright, let's look at what the problem asks. We're given a binary string, which is just a bunch of zeros and ones, and a number k+. Our mission is to find the longest possible subsequence from this string that, when read as a binary number, has a value less than or equal to k+. We can even have leading zeros, which is a nice little hint. Let's walk through an example to make this concrete. The input string is 1,000,1010 inches, and k is 5. This means we need the longest string we can build using characters from the input, in order, whose binary value is 5 or less. The slide points out that we can form 00100 by picking some of the characters. This string has a value of 4 in binary, which is less than 5, and its length is 5. We can also make 00101, which has a value of exactly 5, and is also 5 characters long. Since we can't find a valid subsequence longer than 5, our answer is 5. So what's our first idea? The most straightforward approach is to try everything. We could generate every single possible subsequence. Check if its value is less than or equal to k approach, and then keep track of the longest one that works. But a string with n characters has 2 to the power of n possible subsequences. If our string has 1,000 characters, that number is astronomically huge. This brute force method would time out for sure. We definitely need a smarter way. Let's think about our goals. We want to maximize length. What contributes to length? Both zeros and ones. What contributes to the value of the number? It's really just the ones. This leads to a key insight. Zeros are our best friends here. We can add a zero to our subsequence, increase its length by 1, and it won't increase the binary value at all. So a good starting point for a greedy strategy is, let's just take all the zeros. So if we take all the zeros, what about the ones? We want to add as many ones as we can without exceeding kv. Which ones should we prioritize? The cheapest ones. A 1, at the very end of a binary number, adds a value of 1. The next one over adds 2, then 4, and so on. The ones on the right are much less expensive than the ones on the left. This suggests the perfect greedy strategy. Let's build our number from right to left. As we scan the original string backwards, we'll take every zero we see. When we see a 1, we'll check if adding it would break our budget k-intervals. If it fits, we'll take it. If not, we have to skip it. Okay, here is the complete Python code that implements our greedy strategy. I know it might look a little dense at first, but it's actually doing exactly what we just discussed. Don't worry, we're about to go through it piece by piece. First, we set up our tools. We have a variable called cnt to count the length of our subsequence. We have s_sub_our_sux, which stands for sum, to keep track of the binary value we're building. And I will be our bit position counter, starting from 0 for the rightmost bit. Then, the loop begins. We're iterating through the string s in reverse, from the last character to the first. Inside the loop, for each character, we have a simple choice. If the character is a 0, that's great. We just add 1 to our length counter. It's a free point. If the character is a 1, we have to do a check. The value of this one is 2 raised to the power of I. We ask, is our current sum plus this new value still less than or equal to k? If the answer is yes, we can afford it. We add the value to our sum, and, of course, increase our length counter. Finally, at the end of each loop, we increment I to move to the next bit position to the left. So how efficient is this greedy approach? It's fantastic. The time complexity is big O of n, where n is the length of the string. That's because we just make a single pass through the string. And for space, we only use a handful of variables to keep track of our count and sum. This means the memory usage is constant, or big O of 1. It doesn't grow with the input size. This is about as efficient as you can get. So let's recap the main ideas. The problem was about finding the longest binary subsequence with a value under a certain limit. The brute force was way too slow. The key was to find a greedy strategy. We realized that zeros are always a good choice, because they add length without adding value. Then, by processing the string from right to left, we could consider adding the ones starting with the smallest place values first, which allowed us to pack in as many characters as possible without exceeding our limit k. And that's a wrap on this problem. I hope this explanation made it clear and the greedy logic clicked for you. If this was helpful, please hit that like button, subscribe for more Leetcode breakdowns, and feel free to ask any questions in the comments. And hey, every boba helps fuel more content. Thanks for watching, keep up the great work, and I'll see you in the next video.